So heart rate variability is something that is becoming quite familiar within today's kind of health community, fitness community, I would say just in general. And that's because so many wearables have adopted this metric. You look at things like Oura Ring, Apple Watch, Fitbit, Garmin, Whoop, all of them have some type of HRV metric. So it has people kind of ask the question, well, what is heart rate variability? So heart rate variability at its core, the easiest way to understand heart rate variability is it's the variation in time or the variance in time. So how much time differs in between adjacent heartbeats. The reason why this is important is because the heart does not operate like a metronome, or it shouldn't. So I like to kind of provide a very basic or I guess explanation to people. Most people are familiar with heart rate. So they'll utilize, a heart rate monitor, or even if they go see their physician, like they'll get their blood pressure taken and they'll get their heart rate taken. And so I like to use easy math. So if somebody has a heart rate of 60 beats per minute, that means that over the course of the minute, over the course of a minute, their heart beats 60 times. So then you could deduce that on average, there was 1 second that came in between each heartbeat. So every second, the heart beat. Now, that would not be an incorrect understanding, I would say, of how an average heartbeat works or the heart rate works, but that's not the way it does work. The heart rate wouldn't be exactly 1 second in between each in between each heartbeat. There's fluctuations in times that occur. And this occurs for many reasons, but the primary reason that there's change in between heartbeat is because there's change in heart rate over the course of one respiratory cycle. So as we inhale, the heartbeat is actually going to naturally increase. So heart rate is going to increase and goes faster. And the reason it goes faster is due to some immense physiological changes that are happening. One is oxygen delivery and oxygen rate delivery. So we know that as we inhale and we have oxygen to deliver within the blood, that we want the heartbeat to beat faster to deliver it to all the muscular tissue and organs that need oxygen-rich blood at that time. The other one is also too, because when we inhale and the lungs expand, the heart actually will shrink in size. And when it shrinks in size because of lung expansion and the pressure that it's occurring, then it's going to start beating faster in order to get blood out of there because it doesn't have room to expand. And then on the opposite end, as we exhale, heart rate comes down. And there's multiple reasons for this. The heart has more space. Also, too, we don't have as much oxygen to be delivering at that very moment. But then the other thing, too, is that it's mediated by our 10th cranial nerve, the vagus nerve, which is directly a link to our parasympathetic nervous system. So we see the heart rate start to decrease. So it increases on inspiration, decreases upon exhalation. That's what we call respiratory sinus arrhythmia in physiology. And that's a naturally occurring process that is the primary influencer of heart rate variability. So why is this important? The reason that this is important it's because we see that a heart that is more and a cardiorespiratory fitness system that is more adaptable to all of the trillions of processes that are coming and going, and then also to stress, is one that can indeed adapt by changing its regulatory speed. One that starts to regulate itself like a metronome is one that's basically screaming out and saying, uh-oh, something is off. Like there is something that is moving us out of this state of homeostasis, this regulatory state, and shifting us over into this state of what we call allostatic load, which is basically our stress response being engaged. So we do have two branches of what's called our autonomic nervous system. Autonomic nervous system was once thought to be kind of outside of our regulatory control. We couldn't exercise volition, but we know that we can indeed exercise a lot of volition. But if we're not thinking about it, it still occurs. It's still automatic. Yeah. And a part of the autonomic nervous system is your brain, is your heart, it's your lungs. You're always going to breathe. You're always going to have a heartbeat as long as you're still living, if the autonomic nervous system is working effectively. The two branches are the sympathetic and parasympathetic nervous system. There's actually a third branch, which is the enteric nervous system. That's your gut, and it's very much linked, but a lot of times we just focus on sympathetic and parasympathetic nervous system. When we are able to control or modulate both of those at will, which a lot of people, everybody has the ability to do it, but when we're really stressed, we kind of lose control of our ability to modulate those. That's where we start to see dysregulation, is when we're not modulating them. So the sympathetic nervous system is typically associated with the fight or flight response, and the parasympathetic nervous system is typically associated with our relaxation response. These are not two linear types of nervous system links. Like one isn't turned turned on and the other's turned off. They can actually modulate like a seesaw, or they can work together, or they can work antagonistically or against each other. But this autonomic nervous system is really kind of the key physiological regulatory mechanism for our human stress response.